Hi, my name is Giovanni Canales. This is Math 150, Section 0732 with Professor Barajas. Problem is 10.3.17. The question states, the average daily volume of a computer stock in 2000 was mean 35.1 million shares. According to a reliable source, a stock analyst believes that the stock volume in 2004 is different from the 2000 level. Based on a random sample of 40 trading days in 2004, he finds the sample mean to be 32.3 million shares with a standard deviation of S equaling to 12.8 million shares. Test the hypothesis by constructing a 95% confidence interval. So step 1 in this problem is to determine the null and alternative hypothesis. The equation, the problem states that the first mean in 2000 was 35.1. So the null hypothesis is 35.1. Now the alternative hypothesis in the question states that it changes, so it does not equal to 35.1. So they want to test that statistic. So the mean in this problem is 32.3. The standard deviation is given to us at 12.8, and the sample size is given to us at 40. And the degrees of freedom is always n minus 1, so 40 minus 1 is 39. So that's the first step to determine the null and alternative hypothesis. The second step is to construct a 95% confidence interval about the sample mean of stocks traded in 2004. So a confidence interval has the following bounds, where x bar is the sample mean, TA divided by 2 is the critical value, S is the sample standard deviation, and N is the sample size. So in this equation given to us, to find the lower bound, we must just input the stats given to us and calculate the lower bound. So it's x bar minus TA divided by 2 times S, which is the standard deviation, and divide that by the square root of N, which is the sample size. First we need to determine what's A. So 1 minus A times 100% equals 95%, which is our critical value. 1 minus A equals 0.95. We multiply the percentages, and then we subtract 1, so A is equal to 0.05, and then divided by 2 is equal to 0.025. So that's how we determine A. And so that will be your critical value, and in order to get that, you have to find the inverse T and just input that into your function in your calculator. So you go to second distribution, and then you input that calculation into your calculator. Second distribution, and then you look at invert T because it's a T distribution, and you input the area, which is 0.025, and the degrees of freedom, which is 39, and you calculate that, and it'll be given to you 2.023. Now everything else we just put into the equation, and to get the upper bound we just add, lower bound you subtract, and as long as you put in every number in there in the equation, you'll get your answer. So an easier method to be used is the T interval function in your calculator. That's the fastest way. So you go to second, you go to stats, you go to test, and then you go to T interval. And then you click stats, you input every number in there, mean 32.3, standard deviation 12.8, N should be 40, and you try to calculate a 0.95 confidence interval. You calculate it, and there you have it. 28.206 is your lower bound, and 36.394 is your upper bound.